First, where is that if you want to take a look? We go to our NaML examples repository, we click on webinars, and here you will see how to estimate the ML performance of deployed models folder. Click on that, and you will see performance estimation regression notebook. You click on it, and that is the notebook that I already show. I have it running locally. So let's just get it started. I run it just to make sure that it actually doesn't break, because when you show stuff in live presentations, code always breaks. So let's hope it doesn't happen now. So quick walkthrough. What we're gonna do? We're going to just to show you kind of the end-to-end process. I'm also gonna train the model first. I'm gonna prepare the model for training. I'm gonna train it. I'm gonna make predictions. And then I'm going to simulate kind of a production environment for which we don't have ground truth. We're going to estimate performance, and at the end, we're going to compare this estimated performance with realized performance to see whether the estimation was reasonably correct and whether we could have used it to really figure out what's going on with our model. So now let's go through it step by step. First, we import the data. We just import some libraries to read the model. We import pandas. We import something to train our model. In this case, is going to be like gradient boosting. We're going to actually load the data, not import the data, and we just load it with whatever loading library we have. And we see the data here. What we're trying to predict is number of bikes shared in some kind of bike sharing application. Before we go into the model building, we'll have to drop some things. For ease of modeling and just for presentation purposes, I'm dropping everything that's not a number because I don't want to deal with encoding and stuff like that. I will also drop features casual and registered just because you can just add them up to get the target. So we'll be cheating a bit if we included them. So let's drop them. And I'm just going to actually run this. Hopefully it still works. And now let's split the data. So we're going to split our data set in our train subset, our testing data set, and our production data set. Again, I don't have validation. I'm not optimizing hyperparameters. I'm just doing the minimum thing possible. And then we just train our models with default parameters, some random state, and voila, it's trained. It's not a big data set. Then we're going to make predictions for our training dataset, for our testing dataset, and for our production dataset. Now, what we need, as I already mentioned, we need our reference dataset. And as I again already mentioned, we can use our testing dataset as our reference for which we want to say that performance there is for sure satisfactory. So we are preparing our data by defining what is the reference dataset. Just literally call it reference. We'll copy our test dataset. And there's two things that we need to add to it, which is our predictions and our actual target. So here we take the features, we add our predictions, and we add the target. And that's it. And we're going to do very similar things for our analysis dataset, so the dataset for which we want to know what's going on, what's the performance. And again, we just take the features and we add our predictions. An important thing here, of course, we don't add the ground truth because the ground truth is not there yet. It has not arrived. It is delayed. Then we have our data preparation ready. It was really that simple. Then the next step is we're going to initialize and fit our algorithm, our direct loss estimation algorithm. And what do we have here? So inputs, again, as in the slide, we just need to provide what is the column with the predictions. We call it ypred in a very creative way. What is the actual true column? What's the target? We call it the target. So we just provide the name. And what are the metrics that we want to estimate? In this presentation, we have MSE, MAE. We could add some others, but let's stick with those two. And we need to provide all the columns that were used as features in our models. So we're going to do exactly that. We take our trained data set, find the columns, and cast it to list because this argument accepts a list. We initialize it, and then we fit it. It's fitted. That's it. It's done. Then we're just going to estimate. So this is kind of like a dot predict in scikit-learn. Here we're actually estimating, so we're using dot estimate method on our analysis data set. And let's run it, and it's already estimated. NumML provides a very cool way of visualizing the data. So we can again run this, and we will see that for both metrics that we have here, MSE and MAE, we see a plot of how the estimated data looks like for our reference or test data set and our analysis data set. We can control the size of these chunks here, but we don't have to do it. And since I'm very lazy, even for a data scientist, I don't control it. I just go with default value, and we see that we have around 700 data points in every single chunk. And we see that our MSE, after the model has been deployed, even right before deployment, has gone up significantly. And that means that there is potentially a problem. And the same goes with MAE. So we see there is issues. Now, question is, should we trust it? Of course, even if we don't know, we have no way of verifying that. So we should go and investigate. And this is something that I'm going to talk in our next webinar. But for the time being, let's see if we should have trusted, and if going with the kind of recommendation of what is the expected performance is a good idea. So now I'm going to just calculate the performance. Again, using NumML, you could do it using scikit-learn, but this one gives us very nice visualization. So I'm going to go with that. And again, we need to initialize it. What is the prediction column? What is the actual target column? What are the metrics that we want to calculate? And what is the problem type? We're going through regression tutorial now. So this is a regression problem. And we're going to fit it. Why do we need to fit it, you might ask? Because we want to establish what are reasonable thresholds for performance. This is the only reason for fitting. And then we're going to actually calculate the performance. This time we actually need targets because we're not estimating anything, we are calculating stuff. So I'm going to add or assign additional column here, which is the target. And now you see realized performance, and we can do a quick comparison. MSE looks kind of like that there's two spikes here and there, and so does MAE, so they're very similar in our behavior. And we see just from these two plots that MSE was a bit pessimistic, especially here, but it managed to catch the first strong deterioration of the model and also the second one, and then it managed to kind of find out that the model is predicting slightly better than before. So this is something I would definitely be happy to have access to something like that 2 years ahead. Even if the prediction is not perfect, it definitely tells us that something has gone wrong, and we need to be able to figure out what's there and that there is an issue. And the same, of course, goes for MAE. Again, the same pattern, that it finds the first peak, then it kind of recovers and finds the second peak. That's really it. That's how you estimate performance using NumML for models without ground truth.